Lesson 8-2 Scatter Plots, and in this lesson you learn to construct and interpret scatter plots. Why is it important? Because scatter plots allow you to look for trends in data. Let's take a look at this activity. The sales and advertising costs for 10 of the largest US industrial corporations are shown in the chart below. Use a graphing calculator to create a scatter plot of the data. Definition of a scatter plot, write this down, is a graph that shows the general relationship of two sets of data. Remember, we talked about relations in section 1. So this basically tells you more about the relationship of sets of data. But in this case, in this activity, we will not be using a calculator. For our own purposes, I use GeoGebra. That is free for you to download, put it in your computer, okay, so it can help you at home for graphing. In any case, you are given this set of data, sales in millions of dollars, okay, for A to J companies, and the advertising costs in millions of dollars for these companies as well, okay. And after I plotted all these points on GeoGebra, this is what came out. These are your points, okay. And what do you notice about these points? These points look scattered. Well, by the reason why it's called a scatter plot. And let's answer the questions that follow. Does it appear that there is any relationship between the sales and advertising? And we know that it appears that greater sales is related to greater advertising. How do we know that? Because if you notice letter G, okay, you have letter J, you have sales is less than 500 and your advertising is less than 2,000. And as your sales go up, let me label this, okay, this is sales right here, okay, and this is cost of advertising. Oops, sorry, cost in ads. So if you notice, okay, as your sales go up, the cost in advertising also go up for these letters anyway, okay. So it appears that the greater sales is related to greater advertising. Are there any cluster of points that are somewhat separated from the other dot points? If there are, describe the characteristics of each cluster. If you notice this this cluster right here, basically, okay, are very related to each other, since as the sales go up, your cost in advertising also go up. But if you notice right here, these 2 points, okay, are clustered in such a way that as the cost in advertising goes up, the sales doesn't really go up that much, okay, and that is what we want to point out. 2 points show relatively low sales and high advertising, okay, and that is a good example of a scatter plot. Now look at the scatter plots below. Let's look at the first one. If the points appear to suggest that the line slants upward to the right, there is a positive relationship, okay, which means this, okay, if it tries to slant upward, something like that, okay, that is a positive relationship. If it points appear to suggest that the line slants downward, there is a negative relationship, something like this, okay. So if you notice, it slants downward, the dots are collectively bunching so that it looks like it's slanting downward. And the last part, if the points seem to be random, then there is no relationship in this cluster of data here. You don't really know if it's going up or going down. So in this cluster of data, there is no relationship, okay. So look at the scatter plot of sales and advertising costs on the graphing calculator, the one that we just did a few seconds ago. The points in the scatter plot are spread out. There appears to be no relationship between the amount spent on advertising and the amount of sales. Basically, this is what I'm saying. Okay, if we go down here in our slot, right here, let me put that up again. If you notice, there is no clear indication, okay, if it's going up, okay, or going down. So with this type of data, okay, we can say that there is no relationship between sales and advertising costs. Okay, let's go back to this one, make that appear again. Okay, the 3. Okay, so that's what we have. There appears to be no relationship among sales. Besides establishing a relationship, scatter plots can be used to study trends or make predictions. So we can make predictions for scatter plots. So let's take a look at this example. Make a scatter plot of the following data, then determine if there is a positive, negative, or no relationship. Okay, what trends do you see? Okay, so you have languages other than English and Spanish spoken at home by Americans, and these are the numbers: 1990, 1980, 1990, 1,572,000 language used at home for as French. In 1990, 1,703,000, all the way down to Portuguese at 361,000 in 1980 and 430,000 in 1990. So what can we derive from this? And this is our scatter plot right here. And if you notice, our scatter plot looks like it's trending, okay, slanting upward. Okay, so since the points in scatter plot are in a pattern that seems to slant upward to the right, the scatter plot shows a positive relationship. So in general, the greater the number of speakers of the language in 1980, the greater the number of speakers of the same language in 1990. Okay, and the secret word for today would be Panthers. Secret word would be Panthers. Okay, thank you for watching.